Assalamualaikum warahmatullahi wabarakatuh. My name is Iden Bardan Bayunugraha, study at Sunan Kalijaga, Yogyakarta, majoring at informatics. I want to explain about calculus, chapter application of integrals, with the topic volumes of solids of revolutions, the shell. There are many methods to find volumes of a solid's revolutions, such as the disk method or the washers method. But actually there is a method which is much simple to do, like the shells method or the cylindrical shells. So, a cylindrical shell is a solid bounded by two concentric rectangular cylinders. If the inner radius is r1 and the outer radius is r2 and its height is h, then its volume is given by this: V equals to area of base times 2 its height. The expression of R1 plus R2 divided by 2, which we will denote by R, is the average of R1 and R2. Thus, V equals to 2P times 2 its average radius times 2 its height and its thickness, which is 2P times 2R times 2H and times 2 delta R. If the shell were very thin and flexible, we could slit it down to the side, open it up to form a rectangular sheet, and then calculate the volume by pretending that the sheet forms a thin box of length is 2πr, its height is h, and its thickness is delta r. Consider a region of the type as shown below. Slice it vertically and revolve it about the y-axis. It will generate a solid of revolution, and each slice will generate a piece that is approximately a cylindrical shell. To get the volume of the solid, we calculate the volume delta V of a typical shell, add, and then take the limit as the thickness of the shells tends to 0. The latter is, of course, an integral, so the strategy is slice, approximate, and then integrate. So, with the use of the formula we got before, we can find the volume of the solid obtained by rotating about the y-axis the region under the curve y equals to f of x from a to b. So here are the formulas. V equals to 2p times 2 integral from a to b times 2 its x times 2 f of x and times 2 dx, or we can say the average radius times 2 its height and times 2 its thickness. And here I have an example of a problem that we should use the shell method. You can pause the video to get it done first, and I will show you the answers later. So here are how we solve the problems before to get the answer. First, we have to know every aspect from the solids that we needed to know to find the answer, like its radius, its thickness, and its height. After that, we can input it all to the formula that we have found before. And finally, we can calculate the volume using the integrals. And finally, we can get the full answer, which is 16 per 5p. If you haven't understand it yet, you can try to search out my references. I hope with the use of the shells method can make us easier to find the volumes of solids of revolution. I think that's all that I can share to you guys about the shells method. I hope you guys can understand it. If there is any mistakes from me, I would like to say sorry. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.